Hi everybody, Mrs. Adams again. So today we're going to run through Bohr diagrams and the electron configurations of the first 20 elements of the periodic table. We're gonna just kind of do a little bit of a reminder and a little bit of brush up for anybody that was struggling in class. So first off, let's talk about groups. We had to talk about what's the difference between the groups and the periods. And as we discussed, the groups are the columns that run up and down. So as you see here, I know it's kind of light, the scan didn't work very well, but we have 1 through 18. Now remember, we also signified them from 13 to 18. We can also say 3A, 4A, 5A, 6, and so on. Couple other reminders again is remember the atomic number is the number of protons. The atomic mass is the amount of protons plus neutrons. The periods run left to right, like in rows. So if you think of it as you read a sentence from left to right, and then when you finish, you put a period at the end. So periods run left to right. Also, another rule to remember is the 2-8-8 rule, especially with us doing the Bohr diagrams. So 2 electrons will go in the first ring or shell, 8 in the second, and 8 in the third. One more reminder as far as protons have a positive charge. They are 1 AMU or atomic mass unit, and they're located in the nucleus. Neutrons have 1 AMU, again, atomic mass unit. They have no charge, they're neutral, and they are also located in the nucleus. And then electrons have a very small amount of mass, so most of the time we say they have no mass. They have a negative charge and they're located outside of the nucleus. From the diagram here, you can also see I labeled where the S block and the P blocks are located, so that'll help us with our electron configurations. Okay, so just kind of a clean slate slide to show you that the first element on the periodic table that we're going to be talking about is hydrogen. So as we take a look at hydrogen, you'll notice that there's a lot of writing on this slide, but I wanted to show you quite a few things. First, I've color coordinated a few things. The period is going to be in red ink. Your atomic number or your number of protons should be in green. Your number of electrons is in blue. Your number of neutrons is in purple. Okay. The other thing I want you to note is your atomic mass is in light pink. So as we kind of take a look through this and we kind of sort through the information, the first thing you see is we labeled what group we're in. Well, if you look to the side again, you have the periodic table of elements chart. And the first thing you see is that we have yellow, right? So that yellow box shows that where we're located in the periodic table. So we are in that first box, group 1, period 1. Our element symbol is H. Our element name is hydrogen. Since our atomic number is 1, that means that our number of protons is 1. So now we need to figure out, though, how many neutrons do we have? Well, if you remember, I told you that to find the number of neutrons, we have to subtract. So we have to do a little bit of math. And the reason why is because the atomic mass is the number of protons plus the number of neutrons. So if we think about it, if you take the atomic mass and you subtract the atomic number, because the atomic number is simply just the number of protons. Well, if we subtract those two, then we'd get the number of neutrons. So if we look down at the bottom underneath the number of shells, I kind of drew the periodic symbol with the atomic mass and the number of protons. And if you look, the atomic mass is 1.001. That doesn't mean that we have any number of protons or neutrons that are under 1 atomic mass unit. What that means is that there are isotopes. And isotopes are the same element with just the different amount of neutrons. And they take an average, and that's kind of what you see. But what we need to do to determine the number of neutrons is take the atomic mass from the periodic table, and we're going to round it to the nearest whole number. So again, if you look up to the top, you'll see that I've done that in pink. Okay, so I took the 1.001 and I rounded it to the nearest whole number and just made it 1. So if I subtract the atomic mass of 1 and the atomic number, which is also 1, we get 0. So in the case of hydrogen, we're actually going to put that there are no neutrons. The other thing you have to think about is that neutrons have no charge, protons are positive, and electrons are negative. Well, if all these elements that we're dealing with have a neutral charge, which means they are not any ions, we're not dealing with anything but a neutral atom. So then that means that our number of electrons has to be equal to the number of protons. So we can look at the atomic number and see that our number of protons is 1. So that means then we're going to have 1 electron to even those charges out. So if you look at the Bohr diagram, I drew the nucleus. Inside the nucleus, you have the 1 little proton, and then I drew that outer shell, because remember, there are no electrons inside the nucleus. So on that outer shell, I drew 1 electron. Now, if you remember too, we need to talk about the electron configurations. So looking at our diagram again, you can see that hydrogen is in the S block. So it's in group 1, period 1, but then I've also got that little block around there and it says it's the S block. So if you look down below, I have our electron configuration and I put 1 in red. And I did that because remember I said that the period was 1 and they're the same color. So when I'm looking at my electron configuration here, that 1 tells me I'm in the first period. We know we're in the S block and we have 1 electron. So our electron configuration for hydrogen is a 1s1 configuration. So another clean slate here, we're looking at our next element, which we're going to talk about, which is helium. And I know I joke around and I say helium is a jerk, but that's only because he doesn't fit our patterns. Okay, so we'll take a look at him in a little bit more detail. So as we take a look at helium, you'll see that helium is in group 18. This is kind of why I call him sometimes a bit of a jerk, because as we move through, you would think he would be in group 2, but he's all the way over on the other side. That does make some sense when you remember our 288 rule, and that we can only have 2 electrons in that first shell. And if every electron represents a proton, then it would make sense a full shell would have to go over all the way on the right with the rest of the full shells. So he's kind of a jerk, but he's kind of not. But he's still located in the first period. His element symbol is He. We know that from his atomic number that he has 2 protons. Now we got to take a look at that atomic mass again. So if we need to figure out the number of neutrons, we're going to take the atomic mass, which is 4.002. Let's go ahead and round that to a whole number, which would be 4. We're going to subtract the atomic number, which again is the number of protons, and that's going to give us an atomic, the number of neutrons as 2. So in this case, we have 2 protons, 2 neutrons, and again, if our electrons have to be equal to our protons so that we don't have a charge, then it's 2, 2, and 2. As we look at our electron configuration, we're still in that first period, so we're 1. And then if you look, I highlighted helium and let you know that helium is also going to have an S configuration. So helium again is that one that likes to be a little different. So he is a 1s and we have 2 electrons, so it's a 1s2. When you look at our Bohr diagram in the middle, again, I put both the protons and the neutrons inside the nucleus. And then on that outer ring, you see that there's 2 electrons on it. At the top of that box, I also just kind of reinforce the fact that this is a full shell. We cannot put any more electrons on that first shell now because it is the 288 rule showing there are 2 electrons and it's complete. So the next element on the periodic table that we're going to talk about is lithium. So as we take a look at lithium, you'll see that for hydrogen and helium, there's these boxes with checks in them. That's because we're going to keep track of all of the electrons that we've placed. So we look at where is lithium located. So lithium is located back in group 1. So we filled that shell and we had to fill it and start a new one. So that means now that second shell is period 2. Our element symbol is Li. The number of protons is going to be 3. And now we're going to have to do that math again. So let's take a look down below, and you'll see that lithium has an atomic mass of 6.941. So remember, we're going to round that to the nearest whole number. So the nearest whole number would be 7. So we're going to take 7, and we're going to subtract the atomic number, which again is the number of protons. 7 minus 3 equals 4. That means that lithium has 4 neutrons. We also know that the number of electrons that are going to have to be the same as the number of protons. So we look at the atomic number, again it's 3, so that means that we have 3 electrons. So as we kind of take a look at how to draw our electron configuration, well again we want to keep track of every place we've been. So we're going to write the 1s2 because we filled up all of the electrons in that 1s2 block. We filled up hydrogen, we filled up helium, and so now we're going to start with 2 because we're in that second period, right? So 1s2, 2s, look at where lithium's located, it's in S block, and there's only 1 electron. Another little thing to think of is when you look at the electron configurations, if you add the exponents, and again, the exponents are the numbers that are up higher, okay? And I put them in blue because we're actually adding electrons. So if I take the 2 from the 1s2 and I add the 1 that we just put in from the 2s1, 2 plus 1 equals 3. Double check, that's 3 electrons. And we can check our work because 3 electrons, well, again, that also equals the number of protons since we have no charge. And our atomic number is 3. So if we have 3 electrons and we have 3 protons, then we double check and we look and yep, we are at lithium. Okay, so by adding the exponents, that can tell us how many electrons we have for the entire element. And in this case, we had 2 plus 1, and that gives us 3. So as we take a look at the Bohr diagram for lithium, you'll see again that in the nucleus, inside that first circle, which is my nucleus, there are 3 of those light green dots and 4 of those dark purple dots. 3 light green dots show you, again, the number of protons that are in the nucleus, and the 4 dark purple dots show you the 4 neutrons that are inside the nucleus. That first shell is only holding 2 electrons, and then we drew that third, or the next shell, right? So that second period, another shell, and there's only 1 electron on there. So again, I can look at my Bohr diagram and count 1, 2, 3 total electrons. And it all adds up with everything else that we're looking at for the electron configurations for my number of protons, canceling those out, and making sure everything is correct. Okay, so as we continue down our periodic table, after lithium, we're going to have beryllium. As we look at beryllium, let's remember where we're at. So looking at where we've been, okay, so we filled the first period. That's the first shell. We're gone, now we're in the second period and we're looking at being in group 2. Okay, so group 2, period 2, 2 shells. Our element symbol here is Be. Like we said, this is beryllium. And we're going to have the number of protons here is equal to 4. So let's take a look then, how many neutrons do we have? So down below, again, we have an atomic mass of 9.012. Round that up to 9. So we have an atomic mass of 9 minus the atomic number of 4, and that gives us 5 neutrons. Here I also just put a little side note that E with the lowercase e with a negative is just shorthand for electron, just because I end up using that sometimes and I want to make sure that I let you know. So for electrons, we have to take a look at how many protons do we have. So we have 4 protons, so 4 positive charges, which means we're going to have 4 negative charges. So our number of protons being 4, that makes our number of electrons 4. So then we got to figure out that electron configuration. So we look at our checked boxes again, and you can see that we've checked 1, 2, 3, 4. So 1s2, but now we're in that second period, 2s2. So looking at our blue box, you see that outside of helium, just group 1 and group 2 have that s block configuration. So we have the 1s2, 2s2. And down below, again, I kind of wanted to show you that math. So if I take 2 as the exponent for the 1s2, and I add the exponent from the 2s2, then I get 4. So if I have 4 electrons, then I kind of take a look and I have 4 protons, and that gives me the element of beryllium. Just a reminder too, as we look at our Bohr diagram, we're going to put 4 protons in the nucleus. We're going to go ahead and put 5 neutrons in the nucleus. We put 2 electrons in that first shell. Then we draw another shell, and we only need another 2 electrons. So there are a total of 4 electrons in our Bohr diagram. 2 in the first shell, 2 in the second shell. Our next element on the periodic table is boron. Hopefully it's not too boron for you. Haha, bad. Okay, sorry, my bad. These are Bohr diagrams are getting a little boring. Okay, sorry, you know me. The puns just keep coming, folks. So as we take a look at boron, this is the first time, if you look at our group numbers, we have this 2-number configuration. We have 13, 3a. Well, if you look at my little yellow box, we've jumped. We've jumped a whole bunch there. And that's because, again, we are ignoring those transition metals. Right after element number 20, which is where we stop, the transition metals begin. But since we are not looking at those, and many of the periodic table will have the signification of 13 or 3a. So anytime we're talking about something in group 13 or 3a, you have to be cautious. If you're going to not go with the 13, remember to put the a in there. Because if you tell me that boron is located in group 3, you're going to be incorrect. So be cautious about using that. At the same time, by using 3a, it will actually come in handy as we look at some of the trends down the road. But we're getting ahead of ourselves. So let's just take a look. So we are in group 13, 3a. We are in the second period. Our element symbol, again, is just B. This is boron. We have 5 protons. Let's do a little bit of math now real quick and see how many neutrons we have. So our atomic mass is 10.811. We're going to round that to 11. Our atomic mass of 11 minus our atomic number of 5 gives us 6 neutrons. So if we have an atomic number of 5, which is our number of protons, then that also means that we're going to have 5 electrons. So we have 5 electrons, 5 protons, 6 neutrons. So if you look at our electron configuration, we have 1s2, and look at our checked boxes again, as we're checking them off as we go. 1s1 is checked off, 1s2, 2s2, so now we have to go over to the P block. This is our first element in the P block that we've discussed. So our electron configuration is going to be 1s2, 2s2. We're still in that second period, so it's 2p1. There's only 1 electron in that P block. Okay, so just kind of keeping track of where we've been helps us to keep track of where we are. So if we want to check our work, let's add all of those exponents. We have 2 plus 2 plus 1 equals 5. 5 electrons gives me 5 protons, and again, that element for atomic number of 5 is boron. as you look at our Bohr diagram, we're going to put all of those protons inside the nucleus. So if you count them up, we have 1, 2, 3, 4, 5. So I made a little happy face for you. Sorry, I just had to. So we have 5 protons, and then if you count those neutrons, we have, those are the dark purple, 1, 2, 3, 4, 5, 6. We draw our first ring of our first shell, and there's 1, 2 electrons in that one. And if we have 2 in the first one, we only need to draw 3 more. So we draw that second ring, and we draw 1, 2, 3. So if you look again, in period 3, we only add 1, 2, 3 electrons, but it's element 5. And that's because, again, don't forget that we're adding on. So we had 2 in the first shell, and we have 3 in the second shell, and that gives us a total of 5. Okay, our next element in the periodic table that we're going to discuss is carbon. Okay, so carbon is located right next to boron. So if boron was in group 13, now you see that our carbon is in group 14, or 4A. We are still in the second period. Our atomic symbol is C. We have 6 protons. So let's take a look at our atomic mass to find out how many neutrons we're going to have. We have an atomic mass of 12.011. Round that to 12. We're going to subtract our atomic number, which is 6. And I see a little typo. I didn't do the math right on that, did I? 12 minus 6 does not equal 4. It equals 6. So we have 6 neutrons. I'm not sure how I did that, but it happens. 12, atomic number of 12 gives us 6 protons, 6 neutrons. And again, if our protons are positive and our element is no charge, then we have 6 electrons. We look at our electron configuration, and you see we're going to have 1s2. We're going to keep putting that on there. 2s2, because we filled that up. And now we're at 2p2. Okay, so 1s2, 2s2, 2p2. Add up all of those exponents. 2 plus 2 plus 2 equals 6. So again, if I have 6 electrons in the exponents of my electron configuration, that means I have to have 6 protons. And that gives us carbon. If you look at the Bohr diagram, I have 6 protons in the light green, 6 electrons in the purple. My first shell is holding 2 electrons, and I only need to add 4 more, so my second shell holds 4 electrons. And again, if you look at the bottom in the red electron configuration, period 2, I have the 2s2 and the 2p2. Both of those are in red. And that means in that second shell, if I add those 2 exponents alone, I'm only going to put 4 electrons in that second shell. That's kind of confusing, but as you keep looking as we go through this, you'll see that pattern start to emerge. That first shell, which is still in black, only holds those 2 electrons. Now we're in that second shell, which those in the electron configuration is red, and those 2 electrons in the S and the 2 electrons in the P shell both still go in that second shell. So there's 4 electrons in that second shell. Okay, our next element in the periodic table is going to be nitrogen. Okay, we take a look at nitrogen. Nitrogen is now going to be in group 15 or 5A. It is in period 2. The element symbol is just a capital N. There are going to be 7 protons. Let's take a look at our atomic mass. Our atomic mass is just 14.006. So we're going to round that to 14. Our atomic mass, again, just as a reminder, is the number of protons and the number of neutrons. So we can take 14 and subtract the atomic number, which is the number of protons, and that gives us 7. 14 minus 7 is 7. So we have 7 neutrons in the nucleus. Okay, to determine again the number of electrons, we're going to look at the atomic number again. We have 7 protons, meaning that we're going to have 7 electrons. We look at the electron configuration. We're going to have the 1s2, 2s2. Now we have a 2p3. Okay, so again, if we add up all of those exponents, then we're going to get 7, which tells us 7 electrons total. Tells us we have 7 protons again, and we have 7 protons equals nitrogen. If you look at our Bohr diagram, inside the nucleus, there's going to be 7 green dots representing our protons, 7 purple dots, which represents, our neutrons. The first shell, we're going to have those 2 electrons, and now we need 5 more electrons. So that outer shell is going to be 1, 2, 3, 4, 5. Okay, so 2, 8, 8. The first shell holds 2, but we don't have a full 8. We just need to add 5 more. So we have a total of 7 electrons. So our next element in the periodic table is going to be oxygen. So as we take a look at oxygen in the periodic table, we are now in group 16 or 6A. So again, we're just kind of moving along down the periodic table, but we're still in period 2. The element symbol is going to be O. We're going to have 8 protons because we have an atomic number of 8. So if we take a look then at our atomic mass so we can figure out our neutrons, we see it's 15.99. So remember, let's go ahead and round that to 16. 16 minus the 8 protons gives us 8 neutrons. So then that also is going to give us 8 electrons. We look at the electron configuration, we're going to have 1s2, 2s2, 2p4. Look at our p block again. And if you look, we count how many checks we're going to check. 1, 2, 3, 4. So that makes sense that it's going to be a p4. If we look at our Bohr diagram, I stopped drawing little dots, but I put p equals 8. So again, 8 protons in the nucleus, 8 neutrons in the nucleus. My first shell is going to hold 2 electrons, and then my second shell is going to hold 6 electrons. 1, 2, 3, 4, 5, 6. So my electron configuration for this is going to be 1s2, 2s2, 2p4, and we're going to have in our Bohr diagram 2 shells. The first shell is going to hold 2, and my second shell is going to hold 6. The next element in the periodic table is fluorine. Okay, so let's take a look at fluorine. Fluorine is going to be in group 17 or 7A. We're still in that second period. Our element symbol is going to be F. The name again is fluorine. There's 9 protons. Let's do the math, figure out how many neutrons we need. So we're going to have 18.99 as our atomic mass. Let's round that up to 19. 19 minus 9 equals 10. So then we are going to have 10 neutrons. We have 9 protons, so that means we're also going to have 9 electrons. We look at our electron configuration. It's 1s2, 2s2, 2p5. Okay, 1s2, 2s2, 2p5. If we add up all of those electrons again, just double checking our work, we have 2 plus 2 plus 5 equals 9. I have 9 electrons. I have to have 9 protons. When we do our Bohr diagram, you'll see in that first shell I have 2 electrons. And on that second shell, I'm going to have 1, 2, 3, 4, 5, 6, 7. Okay, so I have 7 in the second shell, 2 in the first shell. That gives me 9 total electrons. 9 total electrons equals fluorine because, again, we have 9 protons and the atomic number is 9. Our next element is neon. They say the neon lights are bright on Broadway. Oh, sorry, my bad. My bad. Sorry for the song. I did try to warn you guys that I am a absolute admitted nerd. I'm fine with that. I'm good with that, actually. Okay, sorry, here we go. Slight detour. As we look at the more detail of neon, you're going to see that we are all the way back over to group 18, 8A. So we're right below helium, which means we have another full shell, okay? So anything on that last column, that group 18 or 8A, means we have a full shell. Our element symbol is neon, or Ne, which again is neon. We have 10 protons. So we take a look at our atomic mass, which is 20.179. We know that's just 20. So we subtract the atomic number of 10, and that gives us 10 neutrons. 10 protons, 10 neutrons, and again, we're going to have then 10 electrons. When we look at our electron configuration, we have a 1s2, 2s2, 2p6. So if you look at our p block, just for fun, let's count the checks that we have in there. 1, 2, 3, 4, 5, 6. So that means that the p block can only hold 6 electrons. It can't hold any more, which makes sense because there are only 8 elements in period 2. And when you add the 2 from the s block, those are 8 electrons total. We have a full shell. We cannot put any more electrons into that shell because it's complete. Okay, so just like helium only held 2 in that first shell and it was full, neon has 2 shells. That first one with 2, which is full, and the second one, which is 8, which is now full, which goes back in line with our 2-8-8 rule. Okay, so I'd like to talk to you a little bit about sodium, but nah, I did warn you that the puns would not stop. All right, so let's take a look at where we're at. So we're looking at sodium, and we're back in group 1. Okay, but we've already filled the first 2 shells. So now we are in period 3, which means we're going to have 3 shells. The element symbol is Na. Again, that's sodium. We have 11 protons. So if we take a look at our atomic mass, 22.989. We're going to round that to 23. If we subtract the number of protons, which is 11, from 23, we're going to get 12. So we have 12 neutrons. So now we got to think about our electrons. So if we have 11 protons, which are positive, then again, we're going to have 11 electrons, which are also, or which are going to be negative, just to make sure that we have no charge. We're not talking about ions here. Ions, again, are elements with a charge. We are simply talking about neutral elements. Our electron configuration is going to be a 1s2, 2s2, 2p6. But we can't stop there because remember that was neon. So we're going to go 3s1. Okay, we are in the 3rd period, and we're going to be in that s block, and we're going to add that 1 electron. So if you take a look, you'll start to kind of maybe see another pattern emerge. Remember, hydrogen was in group 1, lithium was in group 1, and now we're looking at sodium, which is in group 1. And if we look back at all of those electron configurations, all 3 of those end in an S1. So there's a pattern there. So keep track of that. If we take a look at the 1s2, 2s2, 2p6, 3s1, and we add up all of those exponents, so 2 plus 2 plus 6 plus 1, that equals 11. So I have 11 electrons, which is equal to my number of protons. And we're going to take a look at the Bohr diagram. And again, you'll see I have 11 protons and 12 neutrons in my nucleus. I have 1, 2, 3 outer shells to show that we're in the 3rd period. My first shell holds 2. My second shell holds 8. And my last shell is only going to hold that 1 electron because we are in that group 1, and I only need 1 more electron to make my total of 11 total electrons. Our next element of the periodic table after sodium is magnesium. As we take a look at magnesium, now we are in group 2. We still have our third period. Our element symbol is Mg. Our element name, again, is magnesium. We're going to have 12 protons. And let's take a look at our atomic mass. Our atomic mass is 24.305. So if we subtract our 12 protons, then we see that we're going to have 12 neutrons. Don't forget, we're just rounding 24.305 to 24. So we have 12 protons, 12 neutrons, and then since we have 12 protons, we also are going to have 12 electrons. We look at our electron configuration, and we note again that since magnesium is in group 2, it's going to have that S block configuration. If sodium had an S1, then that means that magnesium would have an S2. We're just adding one electron to our previous configuration. So we look at it, and it's going to be 1s2, because remember, we're going to keep track of where we went. So 1s2, 2s2, 2p6, 3, because we're in the third period, 3s2. We add up all of those exponents. 2 plus 2 plus 6 plus 2 is going to equal to 12. And if we take a look now, remember right above magnesium, right, that was beryllium. Beryllium also ended in an S2. And now we're in the third period with magnesium, and magnesium ends in an S2. So if we think of all group 1 elements ending in an S1 configuration, then all of the elements in group 2 are going to end in an S2. So you should start kind of seeing this pattern emerge that the electron configurations can be used as a grid system. If you look at the very last configuration, so in this case, 3s2. Remember, the 3 tells you I'm in period 3. S2 tells me I am in group 2. So we're seeing another pattern here emerging. And then as we look at the Bohr diagram for magnesium, it's kind of hard to see, but they're inside the nucleus, P equals 12, N equals 12. So my protons and neutrons are equal to 24. If I add the 12 protons and the 12 neutrons in that nucleus, then I get that atomic mass of 24. My first shell holds those 2 electrons. My second shell holds 1, 2, 3, 4, 5, 6, 7, 8 electrons. And my third shell, period 3, holds 1, 2. So group 2 elements gives me 2 electrons on that last shell. Hey, Al! No, sorry. Aluminum. All right, so let's take a look at aluminum. Again, you're going to note that we are in group 13, 3A. We're going to jump over and skip those transition metals. But we're still in that third period. Our element symbol is Al. Again, this is aluminum. We have 13 protons. Looking at our atomic mass, 26.981. So we round that to 27. We subtract the atomic number, or the number of protons. My dog is barking, I apologize. And we get 14 neutrons. If we have 13 protons, that means we also have to have 13 electrons. So let's take a look at our electron configuration here. So we use the checked boxes. We have 1s2, 2s2, 2p6, 3s2, 3p1. Okay, so again, if we looked at the element right above there, we would notice that the P1 configuration would be the same. Okay, so we look at boron. Boron was and also ended in a P1 configuration. Now we look at aluminum, and aluminum has a P1 configuration. So that would tell me that all of the group 13 or 3A elements have that P1 configuration. When we look at the Bohr diagram, we have 2 electrons in the first shell, 8, 1, 2, 3, 4, 5, 6, 7, 8 electrons in the second shell. And I draw that third shell and I have 1, 2, 3. So again, group 3A gives me 3 valence electrons, valence just meaning the outer. Okay, so valence electrons, electrons on that outer shell, or that valence shell. Hey, atoms, is our next element silicon? C. So once again, anybody that is possibly listening to this that has never taken my class, I apologize. The puns and the really bad humor is just a natural part of the class. If you're in my class, you're kind of used to it, but if by chance you come across this video and you don't know me, I apologize. All right, let's take a look. So for silicon, we are looking at group 14 or 4A. We are now in period 3. We have 14 protons. We do the math. We take 28.08 as that is our atomic mass. We're going to subtract 14, and that gives us 14 neutrons. And if we have 14 protons, then we have to have 14 electrons. We take a look at our electron configuration, and that gives us a 1s2, 2s2, 2p6, 3s2, 3p2. When we look at the Bohr diagram, again, you see there are 2 electrons in the first shell, 8 in the second, and if we take a look at how many electrons we should have in that fourth shell, again, look at our check marks. And in period 3, we have 4 check marks. So we're going to have only 4 electrons in that last shell. Okay, so we add up our exponents. 2 plus 2 plus 6 plus 2 plus 2 is equal to 14. And if we remember, and if we go back and look at the element that right above silicon is carbon. And carbon had a P2 configuration. And we look at group 4, and all group 4 now is also then going to have a P2 configuration. Okay, so looking again at all of these trends and patterns that we're seeing, for every proton we have, we add an electron to make them even. For each group that we're in, we're going to have based on the number of electrons in that valence shell as well. Okay, so just kind of keeping track, take a look at what's happening. So the next element we're going to take a look at is phosphorus. Okay, so as we're moving right along our period, phosphorus is in group 15 or 5A. We're still in that third period. Our element symbol is P. We have 15 protons. We do the math to figure out how many neutrons. So we have 30.973 as our atomic mass. We round that to 31. We subtract 15, which is our number of protons. That gives us 16 neutrons. If we have 15 protons, that also means we're going to have 15 electrons. If we take a look then at our electron configuration, 1s2, 2s2, 2p6, 3s2, 3p1, 2, 3, 3p3. We add up all of those electrons, that 2 plus 2 plus 6 plus 2 plus 3, that's going to give us 15. So then we take a look at that other pattern emerging, right? So what element was above phosphorus in our periodic table? Nitrogen. Nitrogen was a 2p3, and now phosphorus directly below it is a 3p3. So our pattern is still holding true. If we take a look at our Bohr diagram, we see, all right, the number of protons in there we have is P equals 15, N equals 16. We have 2 of those blue dots in that first shell. 1, 2, 3, 4, 5, 6, 7, 8 in that second shell. 1, 2, 3, 4, 5 in that fifth shell. So if we look at our pattern, if I have 5 valence electrons, those outer electrons, then I should be in group 5A. And lo and behold, I am. So that is another pattern that's holding true that we're seeing emerge as we do our Bohr diagrams and our electron configurations. Whew, smells like rotten eggs in here. Oh, wait, no, that's just sulfur. So as we take a look at sulfur, sulfur now is in group 16 or 6A. We are in period 3. Our element symbol is S. We have 16 protons. If we do the math to figure out how many neutrons we have, we look at our atomic mass, which is 32.06. So round to 32, subtract the 16 protons, and we find that in this case, luckily, we have 16 neutrons. So 16, 16, and 16, because remember, our electrons equals our atomic number, which is also the number of protons. As we look at our electron configuration here, we have 1s2, 2s2, 2p6, 3s2, and 3p1, 2, 3, 3p4. We add up all of those exponents. 2 plus 2 plus 6 is equal to 10. Plus 2 would be 12. Plus 4 equals 16. That gives me 16 electrons, which gives me 16 protons, and that gives me the element of sulfur. If we take a look at oxygen, which, if you remember, was right above us in a P4, it was a 2P4, and it's also in group 6, and we take a look now, and we're in group 6A, excuse me, so again, sorry, oxygen was 6A, and now, but that was in period 2, and now we're looking at sulfur, which is in 6A, but group, or period 3, then we look at both of them as being a P4 configuration. If we look again and count our electrons, that first shell in our Bohr diagram holds 2. Our second shell holds 1, 2, 3, 4, 5, 6, 7, 8. And if our pattern holds true, that last shell, that valence shell of this Bohr diagram should only hold 6 electrons. 1, 2, 3, 4, 5, 6. There we go. So our next element in this series right now is going to be chlorine. Okay, so chlorine is in group 17 or 7A. We are in period 3. Our atomic symbol is Cl. We have 17 protons. If we do the math, we take a look, and we have 35.47 for our atomic mass. We subtract our 17 protons, which gives us 17 neutrons. And then again, we'll have 17 electrons, being that our protons and electrons need to cancel out to a net charge of 0. Our electron configuration is a 1s2, 2s2, 2p6, 3s2, 3p5. We add up all of those exponents. 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 5 is 17. We look and we are in group 7A. So that would mean that we are a P5 configuration, because as I count from the P block beginning, count the check marks, 1, 2, 3, 4, 5. And I look up above to double check, and fluorine was a 2P5. So then right below it, we are a 3P5. So our pattern is still holding. We count how many elements are in that row so far, starting at the S block, 1, 2, 3, 4, 5, 6, 7. So our valence shell should hold 7 electrons. Let's take a look at our Bohr diagram. In our nucleus, we have 17 protons, 17 neutrons. We have 2 electrons in that first shell. 1, 2, 3, 4, 5, 6, 7, 8 electrons in that second shell. And 1, 2, 3, 4, 5, 6, 7 in that third shell. So we have 17 electrons, and we are in, or 7 electrons in that valence shell, and we are in group 7A. So now we are at our pirate element, R. Does that mean all of my puns are gone? We shall see. All right, as we take a look at argon, we are all the way back over onto the right column, the last column. That means we should be in group 18, 8A. We now have another full shell. We have 3 full shells now. Our element symbol again is AR, which means we're pirates. That means all of my puns are gone because our element name is argon. We have 18 protons. We have 22 neutrons. What? All right, let's take a look at the math. So if I have 39.948, that would round it up to 40. And if we subtract 18, yep, that gives me 22 neutrons. If I have 18 protons, that also means I have to have 18 electrons. Let's take a look at our electron configuration. Again, we're just keeping track of everywhere we've gone. 1s2, 2s2, 2p6, 3s2, 3p6. Now, if our pattern holds true, then neon, the one that was right above me, should be a 2p6. And if I take a look, yep, neon is a 2p6. Now again, I'd like to say that all of the elements in the 8A would be 2p6. But remember that, again, I kind of still call helium a jerk. And this might be another reason why. Helium did have that 2s2 configuration. So neon and argon are going to end in a p6. But don't forget that helium is an s2. If I look at our outer electrons, we should have 8 because we have a full shell. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so my 2-8-8 rule still holds. 2 in the first shell, 8 in the second, 8 in the third. And again, if I look over at my chart here with the check marks, that first period, there's only 2 elements in that entire period. That second period holds 8 elements, which is 8 electrons. And that third period holds 8 electrons. So my 2-8-8 rule shows, again, how many elements are in each of those periods. Hey, Adams, can we talk about potassium? Okay. Okay, so we take a look at potassium. Potassium now is right back in group 1. We are in our 4th period, which means when we draw our Bohr diagrams, we're going to have 4 shells. Our element symbol is K. Again, that is potassium. I know it doesn't make sense, but it goes by Latin or Greek, and it just likes to make it complicated because our goal is to make things complicated for you. Just kidding. So our number of protons is 19. If we take a look at our atomic mass, we have 39.09. If we subtract 19 from 39, that gives me 20 neutrons. If I have 19 protons, I have to have 19 electrons. So we have 19 electrons. If I look at my electron configuration, we are going to see if my pattern is holding true. So let's see what we got. We have 1s1 or 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So again, all of the elements in group 1 are showing up with that S1. Hydrogen was an S1, lithium, sodium, and now potassium. All of these are showing up with a S1 configuration. The number before the S1 all depends on what period you're in. So it goes back to that grid system. If I look at my Bohr diagram, We have 2 electrons in the first shell, 8 in the second, 8 in the third, and if I'm right, I should only have 1 electron in my fourth shell because I have 1 extra electron. So all of the group 1 elements have an S1 configuration and they have 1 valence electron. Looking at my Bohr diagram, that does appear to be true. Looking at my electron configuration, that also appears to be true. Folks, congratulations, we made it to calcium. Woohoo! All right, calcium, here we go. Calcium is in group 2. We're still in period 4. The element symbol is Ca. I told you we'd only do the first 20 elements, and so we are at element number 20. There are 20 protons. If we take a look at the atomic mass, 40.078, all right, so we round that to 40. 40 minus the 20 protons gives me 20 neutrons, and then again we have 20 electrons. If we look at our electron configuration, we'll see that again we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. And if we remember looking up at magnesium was a 3s2. If we go to a 2s2, you'll see that we had beryllium. So again, all of those group 2 is an s2. But don't forget that helium is a jerk, and it would make sense that he's in group 2, but he's in group 18, and he is our fourth S2. So that's where it gets a little funky. If we add up all of those valence electrons, 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20. Okay, if we take a look at our Bohr diagram, again, we're going to have 2 electrons in that first shell, 8 in the second, 8 in the third, and then because we're in group 2, we only have 2 valence electrons in our fourth shell. Okay, so let's take a look at all of the patterns and trends that we've seen and kind of review everything that we've gone over. So the first thing we talked about were our groups. And our groups run up and down in columns. And they go from 1 to 18. Or in the case of missing the transition metals, we have 3A, 13, 4A, 14, and we move our way to 13. Groups 1 and 2 are always going to be called groups 1 and 2. Then we have our periods, which are 1 through 7, and those are rows. They run left to right. So again, if you think of you're reading a sentence and at the end you pause to put your period. Okay, so there are only 7 periods in the periodic table. So as you're writing something, and if you say that you're in period 8 or if you're in period 9, then you'll remember that you've got your groups and your periods mixed up. We talked about how our atomic number is just the number of protons. We talked about the atomic mass being the number of protons and the number of neutrons together. We talked about the 288 rule, which is saying that there are 2 electrons in that first ring or in that first shell. Then the second shell can hold up to 8 electrons, and the third shell can also hold up to 8 electrons. So the first shell can only hold 2, the second can only hold 8, and the third can only hold 8. We then kind of talked about, just as a reminder, that protons have atomic mass of 1, and the units are just atomic mass units. So 1 AMU. They have a positive charge, and they're located inside the nucleus. Neutrons also have mass, so it's 1 AMU, again, just atomic mass unit. AMU is just the units. They're neutral, or they have no charge, and they're located also inside the nucleus. Electrons, while they have mass, it is so small that we have a measurement for it, but it's very small. And so for our purposes, we're going to say they have no mass. They have a negative charge, which is vastly important as we move forward. And they are located outside of the nucleus. We talked about valence electrons, which are just any electrons on that outer shell of the element, or we call it the valence shell. We saw a pattern emerging that all of the group 1 elements had an S1 configuration, as well as they only had one valence electron. We saw that with all of the group 2 elements, they had an S2 configuration, and then they had 2 valence electrons. As we skip over the transition metals, so we skip over groups 3 through 12, we take a look at 3A or 13. And the elements that we looked at both had a P1 configuration, and there were 3 valence electrons. We looked at 14A or 14 and 4A, and the 2 elements we saw in that were P2 configurations, and they had 4 valence electrons. We took a look at groups 5A and 15, and we saw the P3 configuration, as well as 5 electrons. We took a look at groups 6A and 16, and they had P4 configurations, as well as they also had the 6 valence electrons. That meaning that 7A or 17 had a P5 configuration with 7 valence electrons, and with the exception of helium, which has an S2 and 2 valence electrons, then the other 2 elements in the P block for periods 2 and 3 in group 18 or 8A had a P6 configuration, and they had 8 electrons. We took a look and we could see that we could count wherever our element was in the period, and as we counted over, that also told us how many electrons were in the valence shell. Okay, so good job, everybody. If you still have any questions, please feel free to let me know, and I will give you guys some further instructions.